Hi everyone. I'm Adit. I'm one of the members of the AWS user group Vadodara, and would like to thank you for taking your time out of your busy schedule and coming to this meetup. This is going to be a special meetup where we'll be talking about more about AWS machine learning, giving a basic introduction about AWS machine learning. To begin with, if you are new to the AWS community, we host regularly monthly second Saturday. We host a meetup at AWS venue. Thanks to Manan Bhai, he's not here, but for providing us the venue. The AWS Community Day, right, or AWS user group here that we are hosting in Vadodara. It's a community of passionate people who are looking to connect and engage with each other around AWS and technologies, right? So if you are passionate about AWS, whether you are a student, whether you are a professional, connect with us, be part of this user group, right? And we can engage and we can speak about different AWS technologies, okay? So we would like to share a few things here. First of all, our AWS meetup page recently did 1,500 followers, right, or 1,500 members. Big thanks to everyone. Big thanks to all the volunteers, members who are part of this group and who have made it possible for us to have this much number of people today, right? So I would like to thank all the social media team. Madhvesh, if you all please come up to this stage, right? Nirmal bhai, Nilesh bhai, Ravi bhai, if you all can come to the stage, Brajesh bhai. So this is the team behind the AWS user group Vadodara, and we have been fortunate enough to be organizing meetups for about 6 to 8 months regularly, and have a good amount of audience, around 60 to 80 people. And we are thankful for everyone who's been part of this meetup, helping us with feedback, and also submitting sessions to speak. What we want to do moving forward is we want to create a culture wherein a lot of people engage with us, give us feedback, and we also want to organize such meetups across your colleges, universities also as part of AWS user group Vadodara. So do let us know if there is any feedback. Do let us know if there is any feedback from your end. We also have a Linktree page. We'll give you the link to you also. So there you can register your feedback to us, what sessions you want, what are the feedbacks you want, so we can help you with it, okay? But yeah, big thanks to everyone who's involved. Thank you, everyone.
200 plus RSVP.
Yeah, this also, today also 200 plus registrations, so it is a big thing for us. Congrats, everyone. So with that, we would like to start today's session. So I'll give a brief about who the speaker is. So the speaker for today's session is Ishan Modi. He's my brother, and we are twins. So what he's going to be speaking about is introduction to AWS machine learning. So I'll hand over to Ishan. Ishan is a machine learning engineer at Glip. He works in Ahmedabad. Over to you, Ishan.
Hi everyone. So today's session is on AWS framework. So our today's session is AWS with machine learning. So how many of you have learned machine learning during your college in some form? Right. Okay. So like, have you guys done like machine learning basics, like to deal with mathematics? What concepts have you covered? If you can just brief me with that. So during college, have you done linear algebra, for example, right? So linear algebra, then calculus. So like these concepts form the fundamental for most of the machine learning applications, right? So we will be discussing a few of them, but like, so let's start with the basics. So what is machine learning, right? So like when the machines understand the the concept or the behavior of the data, that is termed as machine learning, right? So like whenever we see an image, let's say image of a chair, we are able to identify that this is a chair, right? So how does the machine do that? So machine can also identify difference between a chair and a table, right? In machine, when it comes to machine learning, right? So that the basics behind that is, at the end of the day, all of it is numbers, right? So machine learning deals with numbers, and these numbers are used to memorize the data. So that is machine learning, and these numbers also like can be termed as weights, right? You might have heard about weights in deep learning, and like image classification, or maybe applications like decision trees, right? So there are weights associated that memorize your data and help you make decisions, right? So that is basically machine learning. So there are three types of machine learning. First is supervised machine learning, right? So what is supervised machine learning? If someone of you can give that answer.
We need to train the model.
No, so basically supervised, any other person? Yeah, please. Yes, please.
Basically, when we provide our data to the machine, it's not only the raw data, it's data labels which have been provided. So machine
Yes.
can identify and associate label, and that's the training part. Any testing it can associate this with respect to label.
Yes. So supervised machine learning deals with labeled data. So you would have the entire data wherein you would tag that data or somehow obtain the labels. Like let's say there is an image. You want to classify that image. So you should have a label that this image is a chair in order to train your model, right? So that is supervised learning. Supervised learning, like you can break the entire data set into three basically sections. So first is the training data set, then is the validation data set, and third is the testing data set. So generally, when we talk about supervised learning, we distribute our data set into these three parts. Validation is used during the training to verify whether your training is going correctly, it is converging to a value that you require, and testing is used to determine the entire accuracy. So this would be supervised learning, when you are given the data along with its label, like what do you want to classify, right? You have been given that. So like unsupervised, you won't have any labels. So like you just have random data, random values with you, and you need to figure out that which class these value belong to. So there are like various algorithms when it comes to unsupervised. So the main part is clustering. You can use either dbScan or k-means cluster to figure out which cluster your data belongs to, right? So data is broken down to different parts. You have unlabeled data and you want to get labels. So you'll break them into cluster. One of the cluster will belong to, let's say, X label. The another cluster may belong to Y label. So these dbScan and other clustering algorithms would come under the unsupervised learning. Now we move on to semi-supervised learning. So like any one of you have heard about semi-supervised learning, if you can just, yes.
Basically, semi-supervised can be termed as it's a mixture of supervised and unsupervised, where some of our data might be labeled or might not be labeled. So initially, class will be made with a label, and then there might also be some data which does not have label, which will be associated with its commonness of the features to a particular label.
Yes, so as he correctly mentioned, so semi-supervised learning involves a few of the parameters in your dataset when they are labeled, and a lot of them are random samples which have not been labeled. So there are a few techniques you can associate it, like he mentioned, you can do a similarity of the labeled data with the random data and allocate the labels from the labeled data to the random data before training. Or else what you can do is you can train on the labeled data, and then based on the training you can associate values to the unlabeled data, and then you can retrain the model to like get a better accuracy. So this semi-supervised learning is still in research. A lot of research is going on around semi-supervised learning. So if you guys want to pursue anything related to semi-supervised, then it would be a great research field. Yeah, so reinforcement learning is a separate thing. It is more associated towards classical machine learning. So reinforcement deals with the, you give reward based on the results that the model predicts. So currently, like we would be talking more on deep learning side of machine learning rather than reinforcement learning. So yeah, if you want, it is a good field, reinforcement learning. It's mostly used in like game theory and all of those applications. So, like I would like to discuss a roadmap to pursuing machine learning. So, like you guys, most of you like want to begin your journey with machine learning. So, like I would suggest a roadmap for you guys to follow. like if you want to start with machine learning. So the first step is clear your math fundamentals, right? So mathematics forms the core for machine learning. Almost every application in machine learning has some form of mathematics involved, right? So like calculus. So where is calculus used? You might wonder about that, right? Differentiation kahan pe use hota hai when we talk about machine learning. So differentiation is basically used in the commonly known algorithm backpropagation, right? You might have heard it in college, like what backpropagation does, and like it helps you, update the weights that you have in your model. So there, uh, this thing calculus is used. You find the gradient and then you backpropagate. So chain rule, if you guys know, it's a concept of calculus. Chain rule is used, then product rule, like a quotient rule, and a lot of these concepts are used. Then linear algebra. So linear algebra basically when you forward propagate in your network. Let's talk about a neural network. When you are forward propagating, you multiply your weights with the inputs, right? If you guys, there are different layers through which you propagate in the network. At every layer, you multiply your weight with the input that gets fed into the layer, right? So in that, the linear algebra plays an important role. So you need to know these fundamentals. You have to multiply huge metrics or even at times tensors within the network, and thereafter, you'll get the entire final response, right? Trigonometry. So trigonometry is like, it's not that important, but you will have to know a few basic concepts. Let's say, like if you talk about gradient descent, right? Like might come to your mind that why does gradient descent work, how it works, right? So all of those proofs are derived using trigonometry. Why do we need to move in the direction opposite to the direction of the gradient, right? So you might have heard or might have learned that when we update the weights, we update it by a negative value, right? We move in the opposite direction. W is equals to learning rate into the gradient, right? Like W minus weight equals weight minus learning rate into the gradient. You backpropagate using this formula, right? So why do you do the subtraction? So that is like, that has its proof in trigonometry, right? You move in the opposite direction. That is where the you'll be able to reduce the loss at its maximum. So that is trigonometry. Logarithm is basically used to reduce the complexity whenever we talk about machine learning. So logarithm, it helps you convert the multiplication and divisions into subtraction and addition. So that is where it is used. And exponent is just basically its logarithm only. So that is also a concept. Probability and statistics. So like, can you guys tell where probability and statistics are used when it comes to machine learning?
Predictions.
Right. Any specific algorithms that you feel probability and statistics? Yes. Naive bias. Softmax. Yes, correct. Other? Anyone? Yes. So maximum likelihood is another concept of naive bias. So it's a yes. So and statistics, if you guys can point out where. Yes. So regression concepts use a lot of statistics. Other than that, there are like normalization also uses statistics. Regularization is another concept wherein we calculate the norm of a vector. So that is again, yes, no, standard regularization is a concept. L1 and L2 norm.
To make everything in a single scale.
Yes, normalization. Yes,
Standardization is ulta. You have to
convert the normalized scale into, yeah. So that is where the statistical concepts are used. And then there are the EDA techniques where you do visualization. So visualization is just the basics, like you need to break data into chunks and visualize every chunk of data. So these are the math fundamentals that you need to clear before you start pursuing machine learning. So like otherwise you won't understand a lot of concepts in machine learning. Like as I mentioned, gradient descent and backpropagation are the two basic, absolute basic concepts of deep learning. So if you want to go ahead with that, these are the first things that you should pursue, right? And for that you would need these math. Now let's move on to the second part, right? So in your roadmap, the second part would be learning machine learning or deep learning. So If you want to go with deep learning, these are the concepts you need to learn. And classical machine learning is a separate stream. So classical machine learning would involve like algorithms like decision trees, random forest. It would involve naive Bayes and a lot of XGBoost, SVMs. So these algorithms, if you want to learn, you don't need a lot of math, but for especially if you want to go with neural networks, you would need the aforementioned mathematical concept, right? So these are the topics that you like have to learn in order to understand neural networks. So first is gradient descent. So as I mentioned, like whenever you update the weights, this algorithm is used. Optimizers means there are different variants of gradient descent. So that comes under optimizers. So like Nesterov's accelerated gradient descent is there. Adam is there. You might have heard of Adam if you talk about the current day neural networks, right? But how is Adam developed? So there is a hierarchy of gradient descent optimizers that led to Adam, right? So those all, like, people still use Nesterov accelerated gradient descent with stochastic version, right? So you have to like go ahead and look into the optimizers. What are their use cases, and like how do these optimizers actually function, right? You might find these in any of the documentation of, let's say, PyTorch. So there is an optimizer class that is present in PyTorch. So under that, all of these optimizers are listed, and you can use whatever you want. The basic part is that you should know how each optimizer functions, right? So that is the like understanding the key concepts. This means that you need to understand what optimizer does in a neural network. Then we come to backpropagation. So backpropagation is basically differentiation. When you move backward in your network, so there is one forward pass, and after the forward pass, you update all the weights. So the backpropagation helps you update all the weights, right? So that is another algorithm that is used. Then we come on to the loss function. So like, if you guys can let me know a few loss functions. Anyone? Have you guys heard of mean squared error? Squared error loss. So what is square error loss? If you guys, linear regression you might have learned, right? So linear regression mein how do you backpropagate? There needs to be a loss which you backpropagate upon, right? So that is squared error loss. So what is square error loss? Yes. So like there is a predicted value and there is a original value, right? So you subtract these original value and square it, and then you add it for the entire sample set. So that is basically squared error loss. Why do we do this square? If
Just to avoid the negative values.
right.
Because the error can be in both the direction, positive error or negative error.
So that is the exact reason why we square it. अगर negative error आया तो you would end up reducing the loss. You don't want to do that, right? That is the reason why you square it. कि भाई like पूरा loss हमारे पास आना चाहिए. We don't want to ignore the square value. Negative values. So negative values and positive values will एक दूसरे को they'll cut off, right? तो error कम हो जाएगा. We don't want that. Negative value is also a part of the algorithm, right? So that is why we do squared error. Like this is used for basically linear regression. If we want to do classification, what kind of loss do we use? Answer? Can you formulate? Formulate कर सकते हो? What's the? I am talking about classification. Classification means. No, it's not CNN. Yes. So you use basically cross entropy. So there are two types of entropies. It is the basic information gain. So here again, I would like to say that isme bhi there is probability involved, right? Information gain is nothing but it's the probability in its inverse form, right? So usme the values are between 0 to 1, right? For any classification task, either you have a 0 or you have a 1, right? So usme you can use binary cross entropy. So Gini index is basically, it is based on the decision tree, right? Agar decision tree mein if you want to break down it into parts, so you can use Gini index to like आपका डिसीजन ट्री में कौन से नोड पे आपको जाना है, दैट यू कैन कैलकुलेट यूजिंग द मिनिमम गिनी इंडेक्स, राइट? क्या?
Leaf style.
Yes. So उसमें like to break down a decision tree, you can use this Gini impurity. वो impurity का जो minimum आपके पास value आएगा, that node you break it into. जिस node का भी minimum value आता है, you break it into that. So this is about classical machine learning. Like the another loss that is used is one is mean squared error that I talked about, and the other.
Precision recall in classification.
Huh. No. So precision and recall, these are basically evaluation metric. So after you train your model, you will have to evaluate it. So these are the parameters based on which you can evaluate. So there are this confusion matrix is there. So you have like 4 odd evaluation metrics. So based on that you can evaluate. So har ek ka formula is different. You can look it up probably. So precision, recall, and there are a few other parameters as well. So that is evaluation. So like with that, there are 2 basic loss functions that are currently used. एक तो क्रॉस एंट्रोपी है एंड दूसरा मीन स्क्वायर्ड एरर है. मीन स्क्वायर्ड एरर इज यूज्ड इन रिग्रेशन टास्क वेयर इन योर मॉडल इज लाइक लीनियर है, या तो नंबर्स प्रिडिक्ट करने हैं, ऐसा कुछ करना है तो यू कैन यूज मीन स्क्वायर्ड एरर. एंड अगर इफ यू वांट टू क्लासीफाई तो यू कैन लाइक अगर वैल्यू 0 और 1 के बीच में आ रही है, इट इज अ प्रोबेबिलिस्टिक डिस्ट्रीब्यूशन, देन प्रोबेबली यू कैन यूज क्रॉस एंट्रोपी. ठीक है. नाउ वी मूव ऑन टू द एक्टिवेशन फंक्शन.
तो सिग्नल होता है तब हिंज करते हैं माइनस में प्लस में, उस केस में वो जब भी इन दोनों के बीच में वी कैन हिंज ऑल्सो.
हाँ, मतलब जनरल प्रैक्टिस में हिंज लॉस यूज होता है, बट इतना ज्यादा नहीं यूज होता है जितना क्रॉस एंट्रोपी एंड ऑल होता है, क्योंकि मोस्ट ऑफ इट्स बिकम अ स्टैंडर्ड प्रैक्टिस कि भाई यही चीज यूज करनी है. यू कैन प्रोबेबली ट्राई इट आउट विद हिंज लॉस एज वेल.
एब्सोल्यूट कर देते हैं
Hinge loss I don't have a lot of idea with that, right? So activation functions, like what is activation functions? Like, can you guys point me to something? What is activation? No. Anyone?
We match our output that it is our correct input or not, and then we update.
So you guys are going in the correct direction. This happens after we have the layer का output. उसके ऊपर we apply the activation function. But why is it applied? वो हाँ नहीं. So basically activation function is used to introduce a non-linearity in your network, right? Non-linearity means like अगर sigmoid function आप use करते हो, like whenever you like try to predict something, you have a linear regression में क्या होता है, there is a straight line separating two this thing data into 2 parts, right? It classifies whether the data is like, let's say it belongs to class A or class B. नहीं, linear में भी you can do that. You fit a line between the values, right? And उसमें you can get एक line के ऊपर value होती है तो there will be let's say there is an input, you will associate that input and वो input के basis पे आपका output मिलेगा.
तो वो तो प्रेडिक्शन
हाँ, logistic regression में you'll be classifying the values. अभी उसमें your classification would not always be linear, right? मतलब what if there is a circle, उसके अंदर सारी values है एक क्लास की and दूसरी सारी value circle के बाहर है. अभी वो line से कैसे आप, how do you break that into 2 parts? All the values are within the circle and outside the circle. So your boundary is the circle. So you won't be able to break that using a straight line. So that is the reason why we use activation functions. So they'll be able to estimate this circle boundary. Linear boundary होगी तो आप separate ही नहीं कर पाओगे. So that is the reason why we use activation functions. Then the other concepts are bias variance trade-off and regularization. So regularization and those concepts are used to avoid the network from overfitting. So training data पे like if you overfit तो test data पे your model won't perform. So उसमें like you use dropouts, then you scale the weights to a certain value. So that is all covered under regularization. And you need to have a precise trade-off value between variance and bias. अगर बहुत ज़्यादा variance होगा या बहुत ज़्यादा bias होगा तो नहीं चलेगा. You need to have the exact values. And then there is batch normalization. So batch normalization as he mentioned, तो अपना जो weights होता है वो weights को it is used to scale that weights so that all the weights in the entire network come from a same distribution. So that helps your network to converge better. So these are the basic concepts. You can probably look these concepts up. एक के बाद एक you can just refer to concepts. कौन सा क्या करता है, where it is used in the neural network, right? So these are the basics. Now we move on to the state of the art machine learning models. So you might have heard of GPT, transformers, BERT. Abhi, once you have your basics cleared, you can probably move on to these models, right? So these are the models जो अभी like those are getting used now. So इसमें there are vision transformers that deal with the images. So base model is transformer for all of these applications. You can look it up in this paper. So I have linked the paper as well. A transformer, like it was introduced in 2017. It is a model architecture. If you guys are aware of CNN, LSTMs and all of that, so आपको वो पढ़ाया होगा. But transformers, like usually they don't teach in the college. So transformers is just a extended version of LSTMs. So LSTMs, I'll come to that later on. I think it is there in the later on slide. So abhi ke liye, the state of the art models include transformers. Then there is BERT. So BERT is a version of transformer. Transformer का एक component use करके BERT का model बनाया हुआ है. Then there is GPT. Transformer का एक दूसरा component use करके they have created the entire GPT model. And the vision transformer. Vision transformer, basically you feed in an image into the transformer and let it classify the image, or predict whatever is there in the image, right? So these are the models. So you basically need to read this paper. ये paper में पढ़ के what is the architecture, how it is better than LSTMs, CNNs, वो सब, like you'll figure it out when you go ahead and read this paper, right? So that is the this thing. Now we get to like AWS. So once you have your these basics and all covered, so like in the previous module, you can also go ahead and experiment with PyTorch or something like that. So PyTorch के साथ you can train a basic transformer with all of the text, right? So BERT में से you can, like basically you can use a BERT model to classify text or question answer, or like there are n number of applications you can do with language, right? So उसमें you can train the model. And like when you want to train the model on a huge set of data, you would need obviously AWS will be required in that. So these are some of the AWS key technologies that you can use when you go ahead with the training of your model. So ये सारा basics है. There are a lot of other things involved as well. Like in a production environment, there is a role-based system. You have to give roles to your like separate engineers. So a machine learning engineer would have access to the MLOps pipeline, right? He won't have the access to the data analysis pipeline, right? There would be a separate person who would clean up the data and provide it to the MLOps pipeline. So isme you have those things, but they are under the hood of, let's say, SageMaker or something like Lambda. So like everything in machine learning more or less revolves around these technologies. Docker के images भी होते हैं, you can place the image. Base image में से you can create like उसके ऊपर you can build on the models and all, right?
What is special in SageMaker? I can make the pipelines in GitHub pipeline or Action or Jenkins as well. So SageMaker is a very expensive service. But what is so special that I should go?
SageMaker ka, like the collaboration with the Jupyter notebook and the visualization libraries that it provides, and the amount of automation that it provides. It has a lot of scripts already present in the marketplace. You can use like BERT का pre-trained model है तो SageMaker marketplace पे है. You can go ahead, उसको fetch करो and you straight away आपके data पे you use.
मैंने डॉक्टर और एनवायरनमेंट बना के बाद में उसको पुश कर दिया. तो मेरा जेनकिंस भी सब पिकअप कर ही लेगा. लेकिन अगर स्क्रैच से कर रहा हूँ तो आप
yes. So it has pre-built pipelines, right? आपको जो code, you would probably have to write that code. SageMaker already does that for you. A lot of like if you talk about the EDA, exploratory data analysis, आपको data का insights चाहिए, तो data insights also a lot of insights SageMaker automatically provides you. You don't have to query कि भाई मेरे को ये insight चाहिए, वो आपको देगा कि भाई data में ये चीजें missing हैं. There are automated scripts that would give you that. So that is the reason why it has. Yes. So like linear regression. So linear regression, as we said, so it's a basic prediction method. So जैसे मतलब like we have all the data points. अभी data points के around, if you want to predict a value for like a sample set, अगर you are given a sample set and you want to predict के value क्या होगा ये sample set का, right? तो linear regression is used in that case, right? This is a very basic thing. हम लोग XY coordinate पे सारे points है. If a point let's say comes here, उसका value आपको predict करना है Y coordinate. आपको सिर्फ X coordinate दिया है. So based on this generalized line, you can predict the Y coordinate. right? ऐसे this can be in multi-dimension across like there is polynomial regression, तो squared values भी हो सकती है, right? There are a lot of type of regressions. You can go ahead and look into that. But this is just a 2D plane. तो उसमें x दिया होगा, y आपको प्रिडिक्ट करना है. तो आपके पास जितना डेटा है उसके हिसाब से you would be able to predict this line. अभी कोई भी आपको x देगा तो ये लाइन का आपके पास इक्वेशन है, तो you can find the y. But this can be extended into multiple planes. अभी ये z plane में भी कुछ हो सकता है, and you will predict a plane then. Linear regression would help you predict a plane. अभी x and z दिया हुआ है, वो प्लेन के ऊपर आपको y फाइंड करना है, तो you would be able to do that using this approach. So linear regression, this is the formula that is associated with linear regression. You can probably you'll find it in your books maybe. So if you guys are aware about like this is the basic statistic, covariance क्या होता है, variance क्या होता है, right? So this is the formula, that is a statistical formula. अगर आपको let's say you are given 10 data points, x axis and y axis के 10 data point दिए हुए हैं आपको, right? तो how do you predict this line? This is the definition of the line, right? तो ये line आप predict कैसे करोगे if you are given 10 data points? So this is the statistical approach. इसमें if you feed in the values, x का covariance, y का covariance if you find, and दोनों का if you fit in the formula, ये पूरा formula, तो you will be able to get this coefficient. ये formula से this is the mean, right? X का mean, y का mean. This formula से you will be able to get the other coefficient. So this is the line that you will be able to predict using statistics. अभी the same thing is done by machine learning. So statistics में क्या होता है, एक formula होता है. Machine learning learns these weights and वो weights के ऊपर it will be able to. So ये formula से हमने weights derive किए. अभी we will do it using machine learning, right? अभी machine learning paradigm में see these are the weights, the exact same equation, only जो coefficient formula से calculate किए वो weight से replace कर दिए, right? This is the loss function. हमने जैसा बात किया squared error loss है ये, right? So this is the squared error loss and these are the gradient का values. So ये weights की value every time you go ahead you will update these weights, right? तो इससे you will be able to find the W1 and W0 that you earlier found using the statistical method. So this is linear regression. एकदम basic है. This is absolute basic of machine learning. The foremost algorithm, most of the colleges and all will teach you this. Abhi we will move on to, this is just the steps, and let's see an example. So ये जो this the code that I've written here, this does a basic linear regression. ये सब I have written it in just core Python. So I think if you guys are aware about Python in some form, you will be able to understand this. Is it visible? I have generated a random data set and वो data पे we are fitting a line of linear regression. तो ये gradient descent and all of that is done using Python script, right? जो भी concepts हमने discuss किए, all of these concepts are applied in this script. ये this is the gradient descent का function, right? इसके अंदर we are calculating the loss and then stopping at a required point. See if you can see in the data, ये x का वैल्यू है, ये y का वैल्यू है, एंड दिस इज द लॉस. अभी ये लॉस धीरे धीरे कन्वर्ज होते जाएगा एंड फाइनली इट विल कन्वर्ज टू अ वेरी स्मॉल वैल्यू. So this means that आपने लाइन ऐसी पॉइंट पे आ गई है कि जहाँ से द लॉस इज मिनिमम फॉर ऑल द अदर डेटा पॉइंट्स. सो ये लाइक दिस डिपिक्ट्स दैट थिंग, राइट? अभी वी कैन प्लॉट आउट द लाइन एंड द डेटा पॉइंट्स. सो हमने जो रैंडम डेटा क्रिएट किया है, दैट डेटा एवरी डेटा पॉइंट ये एक्स एक्सिस है एंड दिस इज द वाई एक्सिस. तो इतने डेटा पॉइंट्स हमारे सिस्टम में थे एंड हमने ये लाइन प्रिडिक्ट किया है by using the concepts that I just mentioned, right? Gradient descent है, loss function है, activation function है, all of that we have used in this line. activation function would not be there because it is a linear classification. As correctly mentioned, agar logistic hota to we may have used some activation function. Right? So this was an example of this thing. अभी we will go ahead with the transformer model, right? आप लोग you might be curious कि भाई GPT है तो GPT क्या है, right? You might, all of you might be using GPT, right? कौन कौन use करता है GPT, right? असाइनमेंट खत्म करने के लिए तो एटलीस्ट सब करते ही होंगे. So GPT क्या है? GPT is basically it's a language model, right? Language model मतलब we have given a large corpus of data to a model. उसने वो डेटा में से insights derive की and फिर you will ask it any question, it will give you an answer, right? So question answering system is also a concept of language models, right? So how does this GPT come, right? So you will have to again dive into LSTMs, RNNs, right? LSTM पढ़ा है, किसने पढ़ा है? What is the concept of LSTM? बोलो. Tell me.
long short का memory में वो कौन सी रहती memory machine को याद रखनी चाहिए या कौन सी रहती उसको नहीं याद रखनी चाहिए वो control कर.
Right. So RNN was a sequence model. RNN में हर एक मॉड्यूल was one by one going into the system. एक वर्ड आपने प्रिडिक्ट किया, वो वर्ड के बेसिस पे दूसरा, उसके बेसिस पे तीसरा. LSTM में क्या होता था? It tends to like it forgets some information, it gives more weighted to certain information. So it is basically selective read, write and forget. तो वो previous data में से हर एक information को थोड़ा थोड़ा weightage करके ले रहा था. And when it comes to transformers, so transformers form the basis for all of the language models that are used currently. BERT है, GPT है, everything. तो ट्रांसफॉर्मर्स में क्या होता है? इट टेक्स ऑल द इंफॉर्मेशन एट अ सेम पॉइंट ऑफ टाइम. हर एक इंफॉर्मेशन में एवरीथिंग इज गिवन वेटेज. उसके आसपास का जितना भी है, इट इज नॉट अ सीक्वेंस मॉडल. आरएनएन्स में आगे का देखते हैं हम लोग. वी डोंट लुक एट द डेटा दैट इज कमिंग आफ्टर, राइट? वेयरएज व्हेन इट कम्स टू ट्रांसफॉर्मर, हम लोग पूरा डेटा एक साथ देखते हैं एंड वी प्रिडिक्ट वर्ड बेस्ड ऑन द एंटायर नेबरहुड, राइट? तो दैट इज द कोर कॉन्सेप्ट ऑफ ट्रांसफॉर्मर. उसमें दो मॉड्यूल्स होते हैं, वन इज एनकोडर एंड वन इज डिकोडर, राइट? आई डोंट थिंक यू माइट हैव हर्ड अबाउट दिस एनकोडर एंड डिकोडर, बट इफ यू वांट टू लर्न अबाउट जीपीटी और BERT, probably you would have to go ahead and read about this. So BERT uses the encoder module of the transformer. It uses, like, there are 6 encoder modules stacked together and it forms a BERT architecture. And so transformer का एक पेपर ही है, I think I have mentioned it here. So this is the module of transformer. अभी ये जो part है ना, this part, right? You'll figure it out when you go ahead and read this. But this is the encoder module, right? तो इसका 6 बार if you stack this, it forms a BERT. BERT model is the language model that is used. अभी जितने भी AWS के भी, if you go ahead in the SageMaker and you check out, SageMaker में भी there are a lot of modules that are related to BERT, right? तो SageMaker के अंदर there are pre-trained modules. अभी BERT के weights है, वो आपको if you use those weights to predict something, you'll get a better prediction because वो बहुत सारे डेटा पे ट्रेन किया हुआ है. So this module forms the BERT architecture and this module stacked up 6 times forms the GPT architecture. तो ये पूरा ट्रांसफॉर्मर मॉड्यूल है. So हाँ,
हर चीज गूगल करवा के
हाँ, yes. So there would be a huge corpus of data that they might have had, and उसके बेसिस पे ये मॉडल का आर्किटेक्चर बना के they would have trained.
गूगल के रिजल्ट्स आ रहे हैं उनमें से वो अपने आप सीख रहा है और अपने
Yes. Even the queries that you give ना, उसके ऊपर से भी it derives insights. And हाँ, yes. And
अंदर आरएनएन यूज हो रहा होगा क्योंकि
नहीं. So RNN is a sequence model, as I mentioned. इसमें क्या होता है? सारा डेटा you feed in together. So हर एक डेटा का हर एक वर्ड में से it derives insight कि भाई ये वर्ड है और उसके आगे ये वर्ड है, तो how much is this word related with this word? सारे वर्ड्स का होता है, पूरा मैट्रिक्स बनता है.
अभी ये तो बोल रहे हैं कि ट्रेन हुआ उसमें एज हो गया 7.5
हाँ.
इयर्स, अभी 9 इयर्स हो जाएगा.
हाँ.
अभी
हाँ.
1-2 महीने के बाद वो कितना फास्ट ट्रेन होगा वो कंप्यूटिंग पावर पे डिपेंड करेगा या फिर मॉडल की स्ट्रॉन्गनेस.
So the training always takes same amount of time. डेटा जितना होता है, if you train a model from scratch, it would take the same amount of time. अगर आप उसको फाइन ट्यून करते हो, जो वेट्स है वो वेट्स को आप नहीं कर रहे हो, उसके ऊपर की कोई एक लेयर के वेट्स ही यू आर चेंजिंग, दैट इज नोन एज फाइन ट्यूनिंग. यू डोंट वांट टू ट्रेन द एंटायर मॉडल फ्रॉम स्क्रैच, पर जो मॉडल के पैरामीटर्स है वो पैरामीटर्स को फ्रीज करके कोई और लेयर के पैरामीटर्स ओनली यू वांट टू चेंज, राइट? तो दैट माइट टेक लेस टाइम. सो इफ यू वांट टू सेव ऑन टाइम, थोड़ा बहुत ट्वीक करना है, कोई एक आध आपके पास सैंपल है जो फिट इन नहीं कर रहा है, लेट्स से like if you have a sample set of 10,000 and you have 100 samples which are not fitting in that model, तो you will fine tune कि भाई आप पूरा मॉडल स्क्रैच से ट्रेन नहीं करोगे, आप थोड़े बहुत वेट्स को फिक्स कर दोगे and you will train using the other weights, वो दूसरे वेट्स को you will fit it according to this model, छोटे मोटे चेंजेस करके. So that is known as fine tuning. So that is also a concept that is involved.
कोड रिफैक्टर कर दे रहा है और ऑप्टिमाइज भी कर दे रहा है, तो बाय द टाइम जितना कोड ऑप्टिमाइज करने में टाइम लगना चाहिए उससे भी कम में तो वो ऑप्टिमाइज कर.
So again, so GPT जो है ना, that is a language model. So you cannot associate or completely rely on logic for like from GPT. अगर कोई भी कोड बेस का पार्ट आ रहा है, so when it is associated with some kind of logic, you cannot rely on GPT. आप GPT से arithmetic operations नहीं करवा सकते. It might give you correct answer because it has referred through a lot of documentation, but that is purely based on the documentation में जो values है वो, right? If you tell GPT to calculate a few things like a plus b बोल दोगे, like 1 plus 2 बोल दोगे, let's say, and then you tell it कि नहीं ये तो correct नहीं था, then it would respond कि भाई हाँ नहीं correct था and give you something else. So it is a language model. वो it is not supposed to do calculations. It is not trained in that way कि वो calculations कर पाए. अगर आप उसको like let's say if you guys are familiar with some backend framework, JavaScript है, Django है, अगर उसका कोड लिखवाना है आपको तो you may be able to write that because there is not a lot of logic involved. अभी उसमें कुछ एक फॉर्म बनाना है, कुछ टेम्पलेट बनाना है, Django में कुछ एक मॉडल बनाना है, तो those things it can do because it has referred to the documentation. डेटाबेस बनाना है, डेटाबेस में अगर if you write name तो उसके अगेंस्ट स्ट्रिंग ही होगा, उसको पता है because it has referred to the documentation. But if you tell it to do calculations, it won't be able to do. वो लॉजिक नहीं कर पाएगा because it is a language model. So it is trained using language. So if something is trained using language, it won't be able to do calculations. अगर आप उसको calculations करने के basis पे if you train something like that, purely calculation based data दोगे, तो it might be able to do that.
Purely calculation based data.
But अभी like ऐसा मॉडल डेवलप नहीं हुआ है, so लॉजिक नहीं कर सकते.
और अच्छी कर रहा है तो मतलब मैं इसलिए डाउट में हूं कि मैं कहीं गलत
नहीं, बट नहीं, यू शुड नॉट डू दैट. मतलब अभी तक राइट दे रहा है but it's a language model, so I think like would results can vary. It has referred to a lot of data, that might be the reason why it is accurate, but language model say you cannot do logical operations, right? So that is a, so these things I don't think you guys like you would be bored with this. I don't think you'll be able to understand it also. It is better if you refer the paper that I just mentioned. So इसमें जो फर्स्ट वाला लिंक है, यू गाइज रिफर टू दैट. LSTMs के साथ उसको कंपेयर करना कि हाउ इज इट डिफरेंट फ्रॉम LSTM. आई थिंक यू माइट हैव ऑल लर्न LSTM इन सम फॉर्म अगर मशीन लर्निंग परस्यू किया है तो. सो यू कैन कंपेयर दिस विद प्रॉब्ली विद LSTMs के ट्रांसफॉर्मर मॉडल डिफरेंट कैसे है. देन यूल बी एबल टू अंडरस्टैंड कि अटेंशन क्या होता है. हाँ, सो दिस इज बेसिकली अटेंशन मॉड्यूल है. So that is a QKV paradigm. So query होता है, key होता है, and value होता है. Query is basically like we assume that query is something that you need in the output. So जो आपका मॉडल लर्न करेगा वो query में ऐसी चीजें प्लेस करेगा, query का जो वेट होगा उसमें, कि आपके मॉडल को ये चीज आउटपुट में चाहिए. अभी key is your input, कि like input में आपको क्या आना चाहिए, and values is similar to key. So key and values go from like it goes from the encoder to the decoder. We will be able to understand it better if you refer the paper only. So अगर like if you guys want to go ahead and experiment things with transformer modules, abhi I have just like cloned a notebook from open source, like Kaggle से मैंने एक notebook clone किया है. It is on BERT dataset. So इसके ऊपर you can go ahead and experiment using PyTorch or maybe TensorFlow, and you can pick up any base model, BERT का कोई भी model ले लो, and उसके ऊपर you can fine tune it on your data, right? तो ये जो notebook है, if you want I will give the link to this notebook as well. it is basically इसके अंदर you guys like almost have like पूरा उसने like the guy who's built it उसमें he has fine tuned the entire network. So जो BERT का network है उसके pre-trained weights use करके he has उसके data पे he has trained that model. I can if you guys want I can execute and explain, but like हाँ, so it's an NLP application जिसमें you are providing your own data and वो data पे based on that data you can do anything you want. Classification कर सकते हो कि whether the data is a negative sense or a positive sense, or maybe you can question answering जैसा कर सकते हो. If you ask a question it will give the answer. तो पूरा कॉर्पस पे ट्रेन करके देन यू कैन डू दिस. सो दिस इज जस्ट अ 4 epoch, 4 epoch के लिए ही ट्रेन किया है. इट वोंट बी दैट एक्यूरेट. बर्ट का बेस मॉडल होता है उसके ऊपर इसको ट्रेन किया हुआ है. सो यू गाइस probably I'll provide you the link. You guys can go ahead and look it up. Kaggle is the best resource if you want to go ahead and learn about any of these architectures. के ट्रांसफॉर्मर को अगर यूज करना है तो there are a lot of competitions on Kaggle. So you can just go ahead on Kaggle, कोई भी एक competition ले लो, data analysis कर दो to begin with. You should know what the data means, data में क्या क्या है, and then you can like clone any of the pre-trained models ले लो कोई भी, and then you can on top of that build your neural network, right? अभी mostly in industry also mostly the game is of data. चीज़ें ट्रांसफर लर्निंग पे ही चलती है. लाइक कंपनीज डोंट मेक देयर ओन मॉडल्स. सो अगर आप लोग को ये परसेप्शन है कि वी विल बिल्ड आवर ओन मॉडल्स, इट डजंट हैपन. सो वो इट्स वेरी डिफिकल्ट टू डू एंड लॉट ऑफ एक्सपेंसेस आर इन्वॉल्व. सो प्री ट्रेन्ड मॉडल्स जो होते हैं लाइक आई मेंशन बर्ट है, फिर जीपीटी है. देयर आर अ लॉट ऑफ वेरिएंट्स ऑफ बर्ट एज वेल. उसमें आर्किटेक्चर में देयर आर स्मॉल चेंजेस एंड पीपल पब्लिश देयर पेपर्स. So you can go ahead, वो कोई भी एक मॉडल पिक करो and then you train your data or fine tune your data on that model. So अभी गेम पूरा डेटा का है, to be very honest. You need to have data in order to train your model. मॉडल तो कोई भी you can pick, it would give you accurate result because बहुत सारे weights involved होंगे. So there will be a lot of memory involved. So yes, so those are like एकदम basic data sets हैं जिसके ऊपर you can start with your deep learning journey. NLP के लिए there is like no data set. आप लोग you can scrape data from web or probably you can search on Kaggle only. Kaggle पे you'll get n number of data sets.
We are working on an application के बारे में the comedian funny.
हाँ.
तो उसके हम लोग अभी एनालिसिस कर रहे हैं तो उसके सबटाइटल्स निकाल रहे हैं सारे.
हाँ.
और उसमें से एनालिसिस कर रहे हैं कि कब ब्रेक दे रहा है, जार्गन यूज नहीं कर रहा है, और वैसे करके क्लासिफाई करके we are saying कि how will Zakir Khan complete that sentence.
हाँ, तो you can probably use any of the language models for this application. हाँ, so pre-trained model you can pick. आपका जो data है वो data you can feed it in there and उस पे सारे weights को fine tune कर दो.
सेम में करिए फिर उससे फर्क पड़ेगा या फिर लैंग्वेज मॉडल नॉर्मली प्लेन स्क्रिप्ट में भी लिखेंगे तो भी फर्क पड़ेगा?
I mean if you like want to write it on the any GPU पे train कर दो, you can write it on Python or maybe something like that. अच्छा अच्छा अच्छा. हाँ, तो फिर like you can use GPUs as well. Our company also used to use GPUs. Now we have migrated to SageMaker for like a lot of different reasons. हाँ हाँ, but SageMaker एक serverless option भी it gives you, right? So हाँ हाँ exactly. हाँ, so that we had always on GPUs, right? So that is तो very expensive. आप you cannot keep your GPUs always on and उसके ऊपर you can models रख के आप करने जाओगे तो it will take a lot of time. So
using the language construct, right? Understand the sentiment and
प्रॉपर इन्फ्लुएंसिंग यूज करके
One more thing. So we did the registrations now only. Like all of you were registered to be part of this. This was only because of like we're going to be providing lunch or maybe snacks later on. So stay tuned for that. We'll be having snacks later on.
I think
Also
we can have a break if needed.
if you want, we can take also a break for after like 5 to 10 minutes. Also, one more thing. Like if there are more questions, you can also take later on questions so that you complete the session on time. That's all.
So just wanted to explain a few things. So PyTorch, if you guys, anyone of you has used PyTorch or TensorFlow, किसने use किया है for what like application? Out of the students, if you guys, someone has used PyTorch. Okay. नहीं है, किसी ने use नहीं किया है. Okay. I think it makes no sense to go ahead with this then. Okay, I think we may take a break now. Acha? 5 minutes we can take a break because thodu AWS no architecture se, so we shall discuss this after a 5 minute break. Can के basics एक वक्त. Yes, please.